Okay, so we are live.
See guys, the question that we have been asked today's GFG PODT is that there is an array that is given to us. Okay. And we have to find the sum of the largest array element, and the sum should include elements that are not adjacent to each other. Now, what does that mean? So let's say this is our array that is given to us. Okay. In order to collect the sum of the array, if you see the whole sum of this array, it would be something around 5, 10. It will be 10, 10, 20, 30, 35. It will be 135. But that would only be possible if I pick the array element of 110. Otherwise, I cannot do it. The condition that they have provided me in this array is that if I pick the array at or array element that is present at index 0, I can't pick the array element of index 1. Or either if I pick the array element of index 3, that I can't pick array element of 2 and I can't pick array element of 4. So like because these two are adjacent to 100. So that is what I have to do. I have to figure out a combination in this whole array such that that combination sum is the maximum throughout the whole array. So now the question comes that like how we are actually going to solve this problem, because if you see in terms of for loop, the issue that we are facing in this case is, let's say if I pick this one, then I can say, you know what, if I pick this one, I can simply ignore this one, and I will literally pick this one, then I will simply ignore this one, and then simply pick this one and simply ignore this one. But the ultimate sum in that case would be about what, 25. Yeah, but if I pick the array element, let's say 100, I pick 5 and I pick this 5, it would be round about 110. So if you see, out of 25 and 110, 110 is much greater. So what is the condition that I need to employ in order to solve this problem? Now, if you guys have studied about recursion, if you guys have studied about dynamic programming, then you can see that this question is genuinely a question of recursion. Now, what does that mean? See, in recursion, generally there is a principle is followed while solving the recursion. Okay, there are three things that we considered while solving a question of recursion. First one is the base case, that what is the base condition. Okay, the second one is pick and non-pick, that is we are calling a function in which we have pick the element, and then we are calling function in which we have not pick the element. And the last thing is that what is the thing that I want to return. Okay, now in this case what I can do is, the given array to me is at 5, 5, 10, 100, 10 and 5. So the given array to me is 5, 5, 10, 100, 10 and 5. This is the array that is given to me, and the condition is that if I pick this one, then I cannot pick this one, and if I pick this one, then I cannot pick this one. But there can be case now that if I did not pick this one and if I did not pick this one, I should pick this one. Okay, so that should be a case that we should include in this scenario. Or I can say that I did not pick this one, but I picked this one, then I picked this one, and then I picked this one. That would be ultimately be another case. So what do I have to do in this case is I have to apply the principle of pick and no pick. In this recursion call, what I'm going to say, that at present there are going to be two choices that I have. Either I can pick my current element, or either I do not pick my current element. Now, if I pick my current element, that is if I pick this element, then the next call should be for this element. You understand? Because I can't take the adjacent element. So if we are starting from the array index 0, and if we have taken this element, then I cannot conclude or include the preceding adjacent element. I have to move one or two steps forward. That is why we are taking here two steps initiative. Now, if I do not pick my current element, then what do I have to do? I have to consider the next element. So in that case, we are just going to increment our value by 1. You understanding where we am going? See, the thing is that from this given array, so let's say if I pick the array element that is present at index 0, that is at this index, then I cannot pick this element because it is an adjacent. So I literally have to give a call for this one. And that is what we are going to do. What I'm going to say, I am making a call in which from my current value I am taking two steps forward. So directly I am moving toward 10. Okay, now the second case is that I haven't picked this element. I have not picked 5 that is present in the first index. So in that case is what? If I haven't picked this one, just make the one next step call. In that cases it will be I plus 1. So I will directly move to my second value of I. Now by following this principle, the advantage that we are going to have is that if we see or if we take this thing in the form of a tree, we are going to find out that we can have multiple options and multiple ways to explore a particular solution. Because if you see in terms of for loop, it is something like this. It is just like we are starting it here and we are ending it here. But in terms of recursion, from any standard given point of view, I can move to multiple ways and I can have many solutions. So in this case you can see 2, 3, 4, 5, 6, 7 and 8. So I can have multiple solutions in this case, and that is the principle we are going to apply. So what we are going to do, for the given array 5, 5, 10, 100, 10, 5, we are going to start from here. Okay, now there are two cases that is going to happen. Either I can pick this one or either I do not pick this one. So let's say I pick this one, then the sum would be 5, and if I do not pick this one, then the sum would remain this empty. Now if I pick this element, then I have to move directly to the next element. I can't conclude or include this. So in this case the next call would be at 100. Okay, the next call would be at 100. But if I haven't picked this one, then the next call would be at 5. Because if I haven't picked this one, then the next call should be at this element. Okay, then at 100 we have two cases. Either I pick 100, so it will become 105, or either I do not pick 100, so it will still remain 5. Now again we are here and we have again two options. If I pick this 100, then the next call would be at what? At this 5. And if I do not pick this 100, then the next call would be at this 10. So in this case at 105, if I have picked, then the next call would be at what? Would be at 5, which is present at this index. And if I haven't picked it, then the next call would be at 10. The same goes for the principle of truth, that if I am making a call from 5 and I have now reached 10, then it would be the similar kind of recursive tree that we are going to get. And by following this recursive tree, we will ultimately have our solution. Yes, guys, we can actually do this code via for loop, but it will be a bit more complicated because the number of test cases that they have provided us is 10 raised to power 5, and the time complexity that they want from us is O of n, and that would only be possible if we do this problem via recursion. That is what we are going to do. Now let's just look out this code. Yeah. So the first thing is that we have been given this function named find max sum. In this, the array in the form of pointer is given to us and an integer n is given to us. Now we are taking a dynamic programming array. In this, what we are doing is we are just considering the places which we have already met. So what does that means? So let's say in this recursion call I am getting something like 2 here, Okay, and then moving forward in this line, I am again getting 2 here. So if I have got the answer of 2 here, then why should I explore this part again? Because if I know that from this one, from this 2, I'm going to get this kind of solution, and if I store this solution in a DP array, then why do I even need to explore these options? If I find a situation where 2 is there, and if that is stored in the DP array, I can just pick this one and simply return from here. you know it ultimately reduces our time to do the problem, and that is what this vector of DP is all about. Then simply we are just calling the function name f, and in that we are passing the index value of the last element and array and our DP array. Then again, as I told you, we are applying the principle of pick and no pick. So in pick, what we are doing is we are picking the element which is nums of int, and then we are calling what ind minus 2, index minus 2, because we can't, because if I am at this index, where was it? Yeah. So if I am this index, and if I have picked 5, then I can't call for 10. I can't call for I minus 1, because it will put me here, and that would be ultimately become the adjacent element which we cannot take. So that is why we are making a call from I minus 2. That is what we are doing in this case of I minus 2. Now if I do not pick this element, then here see, I have taken 0 as answer, and then the call that I had made here is what? I minus 1. Now comes the base case, that if I is equals to 0, that is index value is equals to 0, that is if I am at this value, that is at the first index, then simply return the array of index. Simply return what? 5. And if I am at any negative value, negative index, then simply return 0. That is what we are doing or considering in this case. Then simply if I am finding something that had already been calculated, then there is no need to go for this call, just simply return from this call. And that is what I have explained to you guys here, that if 2 is already calculated, okay, and I am getting the value of 2 again in my recursion call, and I know that I have already calculated this value here, then there is no need to go down this path. There is no need to go down. We can just simply pick the value from here, come back and return our call. That is what we are going to do in this case. And then finally, because we have to find the maximum sum, that is why we are picking the two options out of it. Now what does this mean? Let's say I take two path, okay, and the recursion tree are going to be down to whatever it can be, and let's say this is the answer that is going to be returned to this array. Okay, now what I have done in this statement is I have picked the maximum of pick and non-pick. Now let's just assume that this one is pick, and let's just assume that this one is not pick. Okay, this one is not pick. Now what I'm saying, that if the value of pick is 5 and the value of non-pick is 10, I am saying that I am going to pick the maximum of pick and non-pick. Therefore, the value of 5 and 10 would be compared, and the maximum of these value will be returned as an answer. That is what we have done in this call. We have called a recursive function will do its job, and finally it will return us the answer of the maximum value, and that we actually want. Now let's just submit this code out and see how this thing will pan out to be. So as you guys can see, it is working perfectly fine. Just remember guys, what we have done in this case is we have taken the recursive function, and that recursive function two calls are made. First one will be that pick call, the second one will be the non-pick call. If I am making the pick call, that means I am picking my current element which is nums of int, and then I am making the recursion call for the two elements away from the current one. That is, if I have picked the element 1 2 3, if I have picked the element that is this one, then I cannot make the call for 2, That is why I'm making a call for I minus 2. Similarly, if this is my element and if I had not picked this, then I am making a call of I minus 1. Just understand this thing. That is what we are doing in our these cases. Okay, and with that we will get our answer. So with that guys, today we have solved the GFG POTT. Unfortunately, we won't be able to solve today's Leetcode POTT because it is related to something like system design, which we are not focusing on right now. So that's all for today, guys. With that, over to you, Shivam.
So yeah, guys, thanks for joining with us. We will catch you up tomorrow.